Hello everyone. My name is Lukasz Piwowar and I'm from University of Wroclaw. And I'm going today to tell you something about making hack art inspired by code and optimization. And mostly I would like to make in belief in something special, in some project. I will tell you more about that later. I divided my talk in 4 parts. The first part is Arduino platform. The second is the demoscene. The next one is research, and the last one is a brighter 3D project, which is rendering a plugin for SketchUp. And let's start from the Arduino platform. How many of you know what Arduino is? Okay, almost everyone. That's good. And how many of you have used Arduino already for some project? Okay, cool. For me, Arduino platform is like a Lego set for adults. You can build from this almost everything, and it is not very necessary to be electrical or to get deep knowledge in electricity, for example, to use it. So this is very interesting. And Arduino board specification it's the true embedded system because it's 5 volt, 8-bit, 60 megahertz and half-hour processor. And especially Arduino Uno, which is on this picture, is using microcontroller board based on the Atmega 328P. And generally, it has 14 digital pins that can be used as input or output pins, and which 6 of them can be used as a PWM, which is pulse modulation width, and can be an output, so it can simulate an analog output. The interesting thing in Arduino world is that you can find almost any sensor for Arduino you can imagine. I just make a screenshot from 2 shops, just typing in Google Arduino sensors, and you can find virtually anything. It starts from few bucks and ends on a few $100. And just to name few of them, it's a proximity sensor, acceleration, humidity, temperature, sound detector, fingerprint scanner, pulse sensor, and many, many more. Almost everything you can imagine can be used at that platform. And I'm gonna tell you some more about projects made in Arduino. My friend went to London and was working at Forrester and Partners at the time. This company is like Microsoft or Google in architecture world. I don't know if you know this name because I'm from computer science world, not the architecture, but probably you know it. And he later returned to Poland and created his first RipRap 3D printer. And then he started to print out parts for the 3D printers and sell it on eBay and Polish platform, which is Allegro. And now he's a CEO at his own 3D printers company, which is called Zmorph. But it all started from this first printer that he made using Arduino platform. I will show you how it works at the beginning. So that was the first printer he ever made, and it was based also on the Arduino platform. And what is interesting, when he started, he didn't get a deep knowledge about electronics and designing such a things and building them, and he found every information on the internet how to do that. I'm teaching students embedded systems using Arduino platform, and this is one of the projects they made. It is called Good Morning Ino because it says good morning in Polish language at random pitch and length, and you can see how it works.
Slow motion.
When you move your hand, it says good morning. The other interesting project I found on the net is this old typewriter.
So I wanted to share a little project that I've been working on. Essentially, it is a manual Smith Corona typewriter.
There's a
That's
voice
been
recognition
rebuilt
system
to
and
take
automatic typing on the old
We're using this
typewriter.
headset and the built-in speech recognition in Windows. This will take spoken words and type it out. I made it a point to interface with the typewriter in the way that a user normally would, so hitting the keys from above and using the return arm to advance in the line. This uses a hello servo. Hello is a test of the typing mechanism. Series. New line. That was a test of the carriage return system. Period.
This one draws fancy designs on X. I know there is one person from Pixar here. Are there any others? Because this lamp looks like this Pixar famous lamp. And with just a few sensors, a webcam, and 6 servo motors, look what can be done. Finally, we built something bigger with the students, and it took them 5 months, a few months to get iteration 1, and let's see what that is. Lucky guy. That was the iteration 1, and that's how it looks at iteration 2. And that took 6th place at the European Rover Challenge at this year. And it just started from the idea. We just like to create Mars rover. We just combine some students, and that's what happens. So if you believe in something, try to do that. And even if you fail, you try it. Okay, you can build virtually almost anything, but be careful. And never try to divide by 0. Because look what may happen if you do. Okay, just a joke. And the second part is about demoscene and what I did 20 years ago. This is the definition of the demoscene from Wikipedia. And it's true, we did music videos that was computed at real time at the platform of that time. And the true challenge at the time was the destination platform. It was like 486 DX 132 MHz computer with absolutely no hardware 3D accelerations. There was only 2D graphics cards that got frame buffer that you can put the pixels inside, and the DOS operating system. Usually we use 256 colors palette or 60-bit colors. It was 656 bits for RGB values of the color. We made 11 demos. 2 of them took first place, 1 was second, and 2 were third. And this is part of our demo from 1998. This thing at the end that was real-time ray tracing, but made every 8 pixels and interpolated linearly along. There was a color interpolation or UV maps interpolations. Okay, but how we do that on such a limited platform? First, we used fixed point math for almost everything. Floating point values, floating point types were available, but were horribly slow at the time. So we store floating point values in integer ones, and we used the first 60 bits to the integer part and the other 50 bits for fractional parts. And this procedure draws a line in a frame buffer. And we need to create such a procedures for everything, for drawing even simple one color triangle, for drawing textured triangle, for drawing textured triangle with a Gurat shading or other type of shadings. So we do everything by hand. We just put the pixels inside frame buffers. And notice that to make it faster, we didn't even use multiplication, because when we like to compute pixel position, normally you just multiply y value by the width of the frame buffer. Because frame buffer width was fixed, it was 320. So we first shifted y value by 8 bits to the left, which is multiplying by 256, and then we shifted by 6 bits to the left, which is multiplying by 64, and then we added. So this was faster than multiplying by 320. Such a trick was used, and everywhere we just use shifting bits to the left, to the right, and similar things. So this is just a procedure to draw, fast procedure to draw a line in a frame buffer. Second, we draw only visible things. So this procedure clips lines to the visible screen range, and it is based on the Cohen-Sutherland algorithm. It can reject very early if line is not visible, or can cut to the screen and draw it. We use similar things for triangles, just to reject them very fast. We used also some now regular algorithms like page flipping. We draw to one buffer while showing the other one, then we swapped. So now it's something normal. Then we just find out how it works. For some effects, we used double buffering. We draw a buffer and then copy it as a whole for graphic card address. If our frame rate drops, we use cheap motion blur effect to mask that fact. So it wouldn't be jumping like it would look like a blurred one, and we just averaged current frames with the previous one to get this effect. We couldn't afford a perspective correct texture mapping, which is a standard nowadays. So we used a trick. We compute correct value over every 8 pixels and then interpolate linearly between them. And it was looking good at this resolution. So it was much faster and working good. This is the equation of the true Phong shading at a point. And we couldn't afford the true per pixel Phong shading as well. So we used environment mapping, and we added this light texture during the texturing process. So instead of computing this every pixel, we just get a value from this texture and add it at proper position, depending on the normal vector at a point. This demo from 1996 shows those tricks in action. It was running smoothly on 386 processors, so even slower. The third part is quite short. It's about my research. I made my PhD thesis on voxel method for realistic rendering, and I started in 2003. And my advisor had a hard time finding a PhD student for that topic. But I believed that it will work, and I believed in voxels at that time and started my PhD. The method consists of few steps. In step one was a discretization from triangles into voxels. Then in step two was direct photon shooting and applying power for initial voxels. It's here. And then voxels and initial photon positions were converted into a set of virtual point lights. And at the last step was using a light cuts algorithm for the final rendering. So that was quite simple. But at that time, no one believed in voxels. Everyone says, "Oh, it will be too slow. It will not work. Why you use that? Why you not do that in regular way, like every others that compute global illumination. And look what happened in few years. What happened few years later? It looks like everyone started to use voxels for global illumination. So if you've got a chance to do something, no one believes in it, and you do, just go ahead and do it, because it may pay. The last link is especially interesting for me. I just find this web page by accident. This is the guy, I think, from Czechy or Slovakia, I'm not sure. And he made this voxels engine that runs on regular notebook, CPU-only notebook. It doesn't use graphic card, and it runs at 600 FPS, which is completely amazing for me. What can be done with voxels. There's also physics computed at voxels, and it's also very, very fast. So this is interesting. Of course, he's able to modify whole environment just by removing or adding sets of voxels at real time. And this is his notebook at HD ready resolution. So it will work virtually on any computer from the last, I don't know, 10 years. Amazing for me. The last part is about my product, which is a brighter 3D rendering plugin for SketchUp. At the time when I was trying to learn some 3D program for modeling, to use it in my research, and I was trying Mod, I was trying 3D Studio, Maya, and all of them was too hard for me, too hard to use. I would need to spend too many time to know how to make something useful in that. Because I don't want to spend as much time, because I don't want to be a professional in modeling. But then I found SketchUp. SketchUp is a free for non-commercial use program that is extremely easy to use because it's extremely user-friendly. And then I learned how to make models in, I don't know, few hours, few days. And now I'm teaching also students SketchUp modeling and rendering in Brighter 3D. And when I started this project, I was not using voxels for global illumination in this project, but my main goal was to make it as easy to use as possible, and the second goal was to try my research on noise-free renderer, because all renders I found generate noise, and the ratio of disappearing of this noise was very bad. And you have to wait a few hours to get rid of noise on the rendered images. And my method doesn't generate any noise from the beginning, and it gets very fast preview after a few seconds, and then the image progressively is getting better and better. What do you think is important for speed today? Not the 20 years ago. It was fixed point math, for example. Anyone? An idea? What can it be? So I believe that my computer freezes. Yeah, I think I need to reboot. Okay, so the most important thing in writing fast code today, I think it's data locality and latency. You can see now the difference of accessing different level of caches to fetch or to store data. So look at the CPU registers are not even measured here, but look at level 1 cache and look on the RAM. It's more than 25 times faster. So at the beginning, of course, I've got my own code for, I've got my own KD trees for ray tracing, and I was using that. But then I decided I don't want to reinvent the wheel, and so I used the absolutely amazing Embry ray tracing kernels. It's made by Intel, one from Intel here. Maybe not, but they do really do job on that. And I use them for first and shadow ray intersections only. And on top of them, I built a noiseless rendering engine. And now I would like to show you how easy to use Brighter 3D is.
Welcome to the 5-minute Brighter 3D tutorial.
Can you make it
Artificial
louder?
lighting.
Louder.
To use artificial lighting, first select the material from the Brighter 3D material library. You can find it in the Brighter 3D materials section. Then, apply it to the wall. Make sure the direct and indirect lights option is on. Press the render button to start rendering. Later, you can go into the material window to adjust your light parameters, like temperature and power.
You've got live preview here, and you can adjust parameters in real time and see the result immediately in this small window.
The second option is to turn
as
your
you change the
material into
material.
light, using the pipette and material window. Sunlight lighting. To use sunlight, make sure the Shadows SketchUp toolbar is on. Turn on sunlight using the Show Shadows button. You can adjust the date and time using these sliders. Check the Allow Sunlight. Press the Render button.
I will skip
HDR
some
lighting.
part.
To use HDR lighting, select the HDR map, then select Direction Only from Mapping mode. Turn your floor material type into Shadow Catcher. Make sure your floor is at 0Y position. You can adjust
I made a kind of demo reel, mainly from my students and users of Brighter 3D Forum renders. and I just get them all and put them in one movie. There's punk rock music, so don't be afraid. But and bear in mind that they are not professionals. So no music. Can you make it louder? A bit louder? Thank you very much. Do you have any questions? Okay, thank you again.